alternating current waveform. Here we can see this is a alternating current waveform. It is a sinusoidal wave. Here on x-axis we have taken time, and on y-axis we have taken voltage or current. It may be of voltage waveform or it may be of current waveform. Now since it is starting from 0 point, so it is a sine wave. This hole is called as positive half cycle, and on this opposite side this is called as negative half cycle. From this 0 to t, it is one complete cycle and it is called as time period. The time it takes to complete from 0 to capital T is time period, or we can say the time it takes to complete one cycle, it is called as time period. Here this represents the maximum value. Now it may be of voltage, so if it is a maximum value of voltage, it is represented by Vm, and if it is a current wave, so it will be a maximum value of current and it is represented by Im. Similarly, on the negative side or on the opposite side, here this is the maximum value, so it may be minus Vm for maximum value of voltage, or minus Im for maximum value of current. Now here we can see this V of t represents this waveform, so it is for voltage and it is for current. So V of t is equal to Vm. Vm is the maximum value of voltage. Then sine omega t represent the shape of the waveform. So it is starting from 0, so it is a sine wave. Then omega is the angular frequency and t is the time in second, and Vm is the maximum voltage in volts. Now here this V of t is the instantaneous voltage. Similarly for current, I of t is equal to Im sine omega t. Now instantaneous value will be anywhere in this waveform. Then next is waveform. Now the shape of alternating current, it may be of sine wave, or it may be square wave, or it may be triangular or sawtooth wave. Now here we can see in case of sine wave, it is also positive, negative, and it is repeating periodically. Similarly in case of square wave, positive half cycle, then negative half cycle, and again it is repeating again and again periodically. Similarly for triangular wave or triangle wave, and for sawtooth wave. Now what is waveform? Graphic representation of the shape of a wave that indicates its characteristics such as frequency and amplitude, called waveform, also called wave shape. Now here we can see we can measure its frequency and we can also see the amplitude. Here this will be the amplitude, this will be the amplitude. For this will be the amplitude, and for this triangle waveform this will be the amplitude, and for sawtooth waveform this will be the amplitude. The number of cycles completed in 1 second, it is called as frequency. Now what is instantaneous value? It is the value of AC quantity at a particular instant of time. Here we can see these are all the instantaneous values: I1, I2, I3, I4, I5. So here these are the instantaneous value. It is the value of AC quantity at a particular instant of time. So this is the instantaneous value, this is also instantaneous value. The magnitude of the waveform has taken at any point of time is called instantaneous value. So this is the another definition of instantaneous value. The value of I1, I2, I3 up to so on gives the value of the sine wave at that instant of time. So it will give the value of sine wave at that instant of time. Instantaneous value of current is represented by small I, and instantaneous value of voltage is represented by small v. Always remember that instantaneous values are represented by small letters. Then next is cycle. A cycle is one complete repetition of the wave pattern. Now here we can see from this 0, this is 0 to here up to t. This is 0 and this is t. So from 0 to t it is one complete cycle, or we can say positive half cycle and negative half cycle. So it is called as one complete cycle. A cycle is one complete repetition of the wave pattern and it is repeating again and again. This is for sine wave, similarly for triangle wave, and similarly for square wave, and similarly for sawtooth wave. Then next is period or time period. The time it takes to complete one cycle of the wave is called period. It is denoted by capital T. Unit of time period is second. Now here we can see how much time it takes to complete one cycle is called as time period, and it is represented by capital T. And the unit of time period is second. Then next is amplitude. The maximum or peak value of an AC quantity is called amplitude. Now here we can see this is the amplitude of this sine waveform. The maximum or peak value, because this is the maximum or peak value of this sine waveform, so it will be the amplitude of that waveform. Amplitude of voltage is represented by Vm. We can also call it as maximum value of voltage, or amplitude of current is represented by Im. We can also call it as maximum value of current or peak value of current. Then next is frequency. The number of cycles completed by an alternating quantity in 1 second is called frequency. So how many cycles completed by an alternating quantity in 1 second is called frequency. The frequency is denoted by small f. Unit of frequency is cycles per second or hertz. The unit, simply we can write hertz as Hz. So the unit of frequency is hertz. The formula for frequency is equal to 1 upon time period, and its unit is hertz. Now let's understand what is frequency. So here we can see for this waveform from this 0 to this mark, it is one complete cycle. So likewise these cycles are repeating again and again. Let's count how many times they are repeating. So 1, 2, 3, 4, 5 and 6. So here 6 cycles are repeating, and how much is the time period? So it is 1 second. So the definition of frequency is the cycles, number of cycles completed in 1 second, it is called as frequency. So here 6 cycles completed in 1 second. So that means the frequency of this waveform is 6 Hz. Now similarly, let's see for this waveform, here 1 cycle, then second cycle, and then third cycle. So here only 3 cycles completed in 1 second. That means the frequency of this waveform is 3 Hz or 3 cycles per second. Then angular velocity or angular frequency. It is the rate of change of angle with respect to time. It is another way of expressing frequency in units of electrical radians per second instead of cycles per second. Now we have already seen that the unit of frequency is Hertz or cycles per second, but the Unit of angular frequency or angular velocity is electrical radians per second. It is the time rate of change in angular displacement. Now let's understand what is meant by that. So angular velocity is represented by omega. Now omega is equal to d theta upon dt, where theta is the angular displacement. Angular displacement, change in angular displacement with respect to time is equal to omega. This is the definition of angular velocity. Now, omega is equal to 2 pi by capital T. So, this is the formula for angular frequency, 2 pi by T radian per second. But we know that frequency is equal to 1 upon T, because frequency is number of cycles completed in 1 second. So it is frequency. So F is equal to 1 upon T. Now if we replace this 1 upon T by F, then we get omega is equal to 2 pi F radian per second.